A very good morning to the LajakLaku top management. We are from UTM SCEE 2193, Section 21, Group B. We are going to present the status of template production for LajakLaku B in December 2021. Our group is led by Aina Nazwani binti Suhari, and then we have Daniel Aiman bin Jaidi, Dale Ashley Dang Huyen, and Danny Chu Shun Hong with me as the group member. Let me give a brief introduction. LajakLaku is the manufacturer that produces health supplement diet tablets called LajakLaku. Our group is in charge of monitoring the quality of tablet production for Type B of LajakLaku tablet. 200 samples observations were taken at random from 3 production shifts run daily, namely morning, evening, and night, in December 2021 for analysis. The first part is Part A. It describes and summarizes the sample data from LajakLaku B in numerical, tabular, and graphical forms. The data given consists of weight, relative density, and tensile strength of the tablets. All the numerical, tabular, and graphical forms which related to this data shown later were obtained by using the pivot table function in Excel. First, we have the weight of templates. From the first table, we can see the number of templates produced at morning, evening, and night are 73, 66, and 61 respectively, with the grade total 200. We can see the analyzed statistic data of each shift as well as the grade total of statistic data of weight data in the table. In short, the sum of weight is 70,185.08 mg. The average of weight is 350.9254 mg. The standard deviation and the variance of the weight are 14.0623 and 197.7478 respectively. From the summary of weight data, we can know the mean, mode, median, and others. The frequency of grouped data with the interval of 10 mg is used to plot a histogram, and the histogram shows a similar shape to the normal distribution graph. Next, we have relative density. In short, the sum of relative density is 17,597.4%. The average of relative density is 87.987%. The standard deviation and the variance of the relative density are 1.9963% and 3.9852% respectively. From the summary of relative density data, we can also note the mean, mode, median, and others. The frequency of grouped data with the interval of 1% is used to plot a histogram, and the histogram shows a similar shape to the normal distribution graph. Lastly, we have tensile strength. In short, the sum of tensile strength is 1418.8 MPa. The average of tensile strength is 7.094 MPa. The standard deviation and the variance of tensile strengths are 0.1961 and 0.0385 respectively. From the summary of tensile strength data, again, we can know the mean, mode, median, and others. The frequency of grouped data with the interval of 1 MPa is used to plot a histogram, and the graph shows similar shape to the normal distribution graph.
Assalamualaikum, my name is Aina Najani. I will be presenting the second part, which is goodness of fetus. So, the question is, the Food and Drug Administration Authority requires that weight of standard tablets produced by manufacturers should be normally distributed with 350 mg and standard deviation of 40 mg. So, to show whether LajakLaku tablets produced in December 2021 were normally distributed, we use the goodness of fit test. We need to create the frequency table first with LajakLaku tablet with suitable range. So from that, we managed to group them into 10 groups. So after that, we need to come up with the hypothesis statement. So for the H naught, the data follow the normal distribution with mean 350 milligram and standard deviation of 40 milligram. For the H1, the data does not follow the normal distribution with mean 350 milligram and standard deviation of 40 milligram. And after that, we need to come up with the task statistic table. In the task statistic table, we need to find the probability for each group. And after that, we need to calculate the task statistic. The total of the task statistic is 2.0113. And next, we will need to come up with the decision rule. Since the least expected values is at least 5 or greater, the total of group is 6. The test statistic need to follow the chi-squared distribution with degrees of freedom, which is k minus p minus 1. Since k is 6 and the unknown parameter is 0, we will get the value 5. And we will use that to look for the critical point, which is 11.0705. So we will reject H naught if the task statistic is greater than the critical point. The conclusion is task statistic is 2.0113, which is lesser than 11.0705, which is the critical point. So we failed to reject H naught. This is shown that LajakLaku tablets produced in December 2021 follows normal distribution with mean of 350 mg and standard deviation of 50 mg. Thank you.
Hi, I'm Dale and I will be presenting on Part C. So Part C is to present the required analysis and comment on whether there is any significant difference between tablet weights milligram from the different shifts. So the table shown here is the data from LajakLaku for type B according to 3 shifts, which are morning, evening, and night. From this data, we can perform one-way analysis variance to test the significance difference between tablet weights from the different shifts. And this is what we got from the ANOVA in Excel. From the summary table, we can get the count, sum, average, and variance for this. Whereas from the ANOVA, we can get the value for sum of squares, SS, degrees of freedom, DF, mean square, MS, F, and p-value and F critical. So for the hypothesis statement, H0, which is mu1 equals to mu2 equals to mu3, and H1, which is mu I not equals to mu j for at least one ij where I is not equals to j, where H1 equals to significance difference exists between tablet weights milligram from the different shifts. Our decision rule is F0.05 equals to F critical is equals to 3.041753, and we reject H naught if F test is more than F0.05 or if P value is less than alpha, which our alpha is 0.05. And our conclusion is, since F test equals to 0.423522, which is less than F0.05, then we fail to reject H0. We can conclude that there is no significant difference between tablet weights milligram from the different shifts at alpha equals to 0.05.
Assalamualaikum. My name is Daniel Aiman Bezaidi and I will explain for Part D, predictions and validity of tensile strength. Since the relative density and tensile strength can represent the tablet's hardness, there is a relation between tensile strength and relative density. The tensile strength depends on the relative density. The figure shows the relationship between tensile strength and relative density that we obtain by using the line fit plot in Excel spreadsheet. The blue plot indicates the tensile strength and the red plot indicates the predicted tensile strength. This table shows the summary output from regression analysis of the tablet LajakLaku B. The value of multiple R is 0.84071, which indicates that there is a strong positive linear relationship between tensile strength and relative density. The value of R square 0.70679 shows a good fit for the data to the regression model. The value of tensile strength can be explained by the straight line of the regression. Therefore, the simple linear regression model is adequate. The hypothesis statement that we use is H0 is beta equals to 0 and H1 is beta not equal to 0. The ANOVA table shows the values for regression, residual, and total. The second table shows the value of intercept and relative density in terms of coefficients, standard error, t-stat, p-value, lower 95%, and upper 95%. For decision rule, the alpha value that we use is 0.05, and the decisions that we get is, first, p-value equals to 1.19794 times 10 to the power of negative 54 is less than the alpha value. Second, the t-test value, which is 21.8468, bigger than the value of t 0.025198, which is 1.96. And lastly, for f-test, the value is 477.2805, bigger than the value for f 0.05198, which is 3.84. Based on these decisions, we can say that there exists a significant relationship between tensile strength and relative density. Based on the results, we can also get the value for alpha, which is negative 0.1725, and the value for beta, which is 0.0826. Therefore, we can obtain the equation for y equals to negative 0.1725 plus 0.0826x. We did the calculation to predict the tensile strength for such tablets that show low relative density values of 68%, 74.3%, and 80.1% by using the equation mentioned before. At 68%, the y value obtained is 5.4443. At 74.3%, the y value obtained is 5.9647, and at 80.1%, the y value obtained is 6.4438. We can conclude that the model is invalid because the range of relative density for this data is only from 82% to 94%. Lastly, based on the results we get earlier, the value of R is equals to 0.8407, which is between 0.7 to 0.89. Thus, we can categorize it as a strong strength while the direction is positive. We can conclude that there exists a strong positive linear relationship between the tensile strength and relative density. Thank you.
Allow me to make the conclusion. By performing goodness of fit test, we conclude that LajakLaku B, produced in December 2021, did follow the distribution with mean 350 mg and standard deviation 40 mg, which are required by the Food and Drugs Administration FDA authorities at alpha equal to 0.05. By performing ANOVA test, we conclude that there is no significant difference between template weights from the different shifts at alpha equal to 0.05. By performing simple linear regression, we can conclude that there exists a strong positive linear relationship between the tensile strength and relative density. In conclusion, we can conclude that quality of tablet production for pair LajakLaku B in December 2021 is good. That's all from us. Thank you.